All right, so it seems that most of you are here already. So without further delay, let's now continue our discussion. So are you guys ready now?
Yes, sir.
Yes.
All right, so wait lang, 15 seconds.
1 minute.
15 seconds lang. All right, so in here, let's differentiate what is a loop and then what is a mesh, because it seems that they share the same meaning, but they are not. Okay, so let's say we have this voltage source right here, then nakabobo naman. All right, so let's have this. There you go. So a much better diagram. Okay, so let us say that we have this kind of circuit. So when we say loop one or loop, okay, so we could say, or we could assume that the flow of current is a conventional flow of current. So let's say this is your loop one. Okay, and then since we also have a voltage source in here, then there is another flow of current in here. So in here, since it is now on the right side, so let's say that this one has a electron current. Okay, ganito siya. Or counter clockwise. No, no, no. This is not electron current. This one is still the same with conventional current, since it's going from positive to negative. So the same is from positive to negative. It's just that this one is counterclockwise. Okay, so clockwise for number one, and then counterclockwise for number two. So number one here is actually a loop. Okay, and number two here is also a loop. Number one here is also a mesh at the same time, and then number two is also a mesh at the same time. Okay, so the difference between a loop and a mesh is a mesh cannot have a loop inside of it. Like for example, we have a third loop, okay, or another loop, okay, so it's now from the outside. So the current that we are assuming is from V1 to R1 to R3 to V2 and going back to V1. So let's say that this is your third loop. Okay. So this number three loop here, or the third loop, so this is a loop, but this is not a mesh. Okay. So that is why we have this word single. Okay, a mesh is a single closed loop series path. Okay, that does not contain any other paths. So meaning it must only contain one loop. Okay, but for our loop number three, this one contains three loops. I mean two loops. Okay, we have loop one and number two. Okay, so that is why we could not say that the third loop is a mesh kind of loop or meshes loop. All right, ang gulo meshes loop. But I mean, this is not mesh. Okay, this is just a loop. All right, so that is why a loop is a simple closed path in a circuit in which no circuit or elements or node is encountered more than once. But of course, it can contain any other paths, or let's say two loops inside of it. Okay, so were you guys able to understand the difference between a loop and a mesh? Hello? Where is the part that you guys are confused? So guys, are we having a progress in here about loop and mesh, or loop versus mesh? So loop is 1, 2, 3, but for mesh it's 1 and 2 only. Any clarification, or are you guys confused? Guys,
Yes.
sure? Sir Paulit.
Yes, sir.
Okay. So, all right. So let me just repeat again. If it's a loop, it can have a loop inside of it. Okay. Like, for example, number 3. Okay. So this is a third loop wherein it has 2 loops inside of it. Okay. So this is an enclosed loop. Okay. So, oops. So this one is connected from edge to edge like this. All right. So as you guys can see, this third loop contains 2 loops inside of it. But a mesh doesn't have any loop inside of it, or it cannot be that there is a loop inside of it. That's why it's called mesh. Okay, so it is a closed loop, okay, having 1 loop only. So that is why our mesh is only loop 1 and loop 2. Okay, but for the loop, we have this loop 1, loop 2, and then loop 3. So did you get it now, Miss Sekdigan?
Yes, sir.
All right.
Sir.
Yes? Question? All right. Okay then, so if you guys do not have a question anymore, then let's now proceed to the next definition of the terminology. So we have here the example of a branch. So as you guys can see, this is a branch. So we have 2 nodes, and then inside of it, we have a component. So this is one branch, and then this is another, yeah, this is not a branch. So this is what I'm talking about. So yeah, it has 2 nodes, but it doesn't have a component between it. So you cannot call this one as a branch. So this is just a path, okay? Just a single path or a single line. And then we have here another example of a branch because it has a component across it, which is a current source. Okay, and this one is another branch. This one is another branch, then another branch. Okay, so are we clear on what is a branch so far?
Yes, sir.
Yes, sir.
All right. So just let me know if there is a part that you guys are confused about. So here is just another example of a node, branch, and a loop. So we have here a node A, B, C, D, E, G. So A, B, C, D, E, G. Okay. So this is a loop outside. Okay. So the one that we have on this example. Okay. A, B, C, D, E, G. So parang nasa labas lang siya. And then we could actually have another loop in here. Okay, so which is A, E, and G. Okay, so those 3 nodes is consists of 1 loop already. Okay, or we could say that we have this E and D as your super node. Okay, that's because this one is like containing most of the components. Okay, or let's just say that when I say super node, it has more junctions than the others. Okay, like for example, this one has a junction on the left side, a junction on the bottom side, and then a junction on the right side. So these are the main nodes of this circuit. Okay. And then for the branch, of course, it's only two nodes. So A, B, 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 C, D, D, E, E, A, A, G, E, G, and so on and so forth. Okay. As long as it has a component between those two nodes. And then for a loop, okay, so we have this A, B, C, D, A. As long as it's a closed loop, it's considered as a loop. Okay. A, B, C, D, E, A. So there should be an E here, but anyway. So A to B to C to D, and then going back to A is a closed loop. So this is one loop, another loop here, another loop here, then another loop here. So you can have 5 loops total in this circuit, right? So just take note that when you say series, you have the same current that is flowing on all of the components. So this is actually the idea of Ohm's law. And then if it's parallel, then they have the same voltage applied across them. So if it's series, the one that is equal with each other or in everything is the current. And if it's parallel, then the one that is equal on everything or on every component is the voltage. Okay. And then we have this typical DC circuit. Okay. So we have the voltage source, we have the R1, R2, R3 up to R8. And then, yeah, we have nodes here, etc. This one is actually like called the super nodes. Okay, and then, but you can also call this one as another node, then another node. It's just that those two are the main junctions of this circuit. Okay, so that is why the word called super nodes. All right, so let's have this example. Okay, and we'll solve this one using KCL and KVL. Yes, Mr. Santa Cruz?
Sir, dun sa sa picture kanina, sir. So yung sa baba hindi siya super load. Yung dalawa sa baba.
Yeah, I think a super node is just well, actually, in reality, they don't have differences. It's just that we say that supernodes are their main source of branches or paths, wherein it has 3 junction, 4 junction, etc. So yeah, this one is also a supernode if you want to consider this one as a supernode. But doesn't really matter if it's a supernode or no. Okay. So, nabanggit ko lang kanina kasi nandito siya. Well, supposedly, lahat naman sila are just nodes, okay, are normal nodes. Okay, doesn't really matter if we have super nodes or just a normal node. Anyway, so in here, if you want to say this one as a super node, then yeah, we have super node A and then super node B. And then the rest are just normal nodes. Right, so we have this circuit right here wherein we have to find the current flowing in the 40 ohm resistor or the R3. Okay, so the flow of current is already given. So we have this conventional flow of current and then another conventional flow of current, which is this counterclockwise. And then we have the third current, which is flowing outside of the entire circuit. Okay, so here's the, so copying ko lang to para may reference tayo. Okay, so just reminder. So it would be better, guys, if you will do this one on your own paper for better understanding. Okay, so it's really advisable that you do this one with your ball pen or pencil and paper. Okay, so yeah, it's okay if you're going to do this one, you know, via your mind only, okay, or impromptu, but it's not that easy to analyze, okay, if you can do that one on your mind only. So I would like you guys to bring out your paper and then, you know, try to analyze it using your own comprehension, okay, though we already have the solutions here, But this is just your references in case you forget something. Okay, so the only tips that I will give to you is you could always start with KCL. Okay, so always start with KCL, Kirchhoff's current law, and then once you're done in getting the let's see expression, like for example at node A we have this KCL, at node B we have this KCL, then you can now proceed in getting all of the loops, okay, on the KVL. So as you guys can see, we have 3 loops, 1, 2, and then 3. So expect that we also have 3 expressions or 3 given formulas, okay, that you'll be able to form. So this is the first expression from your loop 1, and then the second expression from your loop 2, and then third expression from your loop 3. All right. So in here, you can actually write this one. I guess it would be better if we'll do it right here for now. So using a KCL, okay. So we have this super node A and then super node B, okay. So let's say KCL at node A. So again, any current that is entering a node is positive, and any current that's leaving a node is negative. So from here we have I1 that is flowing right here, and then we'll enter node A. So just put here I1. And then we have 2 currents, okay? I mean, yeah, 2 other currents, which has another path. But in here, same. In here, it's also entering the node A, so plus I2. But the other one, okay, which is the I3. So as you guys can see, we have I1 flowing to the A, and then I2 flowing to the A, and then I3 is like leaving our node A. So in here we have negative I sub 3, and then equate is 1 to 0. All right. And then for the node B, so the same logic. So we have I3 entering this node. So we have positive I3. And then we have this I1, okay, that is leaving, okay, this junction letter B. So that is why we have negative I sub 1. And then the same with the I sub 2. It's also leaving the node B. So it's also negative I sub 2. And then do not forget to equate it to 0. So from here, you can form a new formula wherein you can say I sub 3 is equal to I sub 1 plus I sub 2. So basically, I've just tried to remove the negative sign and then come up with a new formula wherein I sub 3 is equal to I sub 1 plus I sub 2. Okay, so the same with this one. So from here, I'll just remove the negative signs and then make it positive. So I sub 3 is equal to I sub 1 plus I sub 2. Okay, so as you guys can see, they are the same with each other. So from there, if you have the same answer, let's say this node A to node B, let's say having this branch, then you can just simply eliminate this one, okay? And then just use the other one as your equation number 1, for example, okay? And then the next one that you want to do is, of course, KVL. Okay, so in KVL, so in here you have to strictly follow your flow of current. So in here we use conventional flow of current. So we will use that one as our basis. So KVL at node 1. So in my case, I always use the sign that is going out on a certain component. So we have here positive, negative, and then positive, negative. So in here, of course, you're going to have a voltage drop. Then, of course, this one will become negative I sub 1, R sub 1. Okay. So it could not be that it will be added to your voltage source. So in this case, we're going to have positive, negative. Okay, positive 10 and then negative 10 I sub 1. So the same with this one. So positive and then negative. So in here, we also have positive and negative, and then positive, negative, and then positive, negative. All right. So at node 1, we have this positive 10 volts, okay, from here. And then from here, we have, just a recall, we have this formula, right? VIR. So if it's KVL, the one that we're trying to solve is the voltage, okay? So in here, we already have the current, which is the I1, and then we already have the resistance, which is the R1. So just copy that one as it is, because the result of that one will be voltage. So negative I sub 1 times R sub 1. Okay. So the same with this one, we have negative I sub 3 times R sub 3. And then, yeah, that's it for the node 1. And then equate that to 0. So were you guys able to follow so far? Hello guys. Nakakasunod ba
Yes,
kayo?
sir. Yes, sir.
Okay, so this is a voltage. The result of this one is also a voltage. The result of this one is also a voltage. Okay, it's just that, the sign is different now, okay, because we are now following the polarity of your circuit. And you don't have enough space anymore. So let's say right here at node 2. Okay, so still KVL. So we have this VIR. So we have this positive 20 volts and then minus I sub 2 times R sub 2. And then we have this minus 40. Oops, sinulat. I3. I3 R3. I3 times R3 equal to 0. And then for the last loop, bakit node to? Sorry, this is not node. This one is loop. At loop 2. Okay, and then the same with this one. This one is not node. This one is at loop 1. Right? And then we have the third loop at loop 3. So we have this positive 10 volts minus I1 times R1 and plus I2 times R2 minus 20 volts and going back to the original one equal to 0. Okay, so from there you can actually already simplify the loop 1, loop 2, and loop 3 into a simpler form by substituting the values that we already have in the circuit. Like for example, the R1, we already have the value of R1, which is 10. The R2, which is already 40. And then from here, let's say you have already substituted all of the corresponding values of your I1, R1, R2, I2, etc., etc. Then you can now use this one. Okay, so you can now use this formula or equation 1. I3 is equal to I1 plus I2. Okay, so our goal in here is to eliminate as many unknown as possible. Okay, like for example, we have 1, 2, yeah, we have 2 unknowns on your, let's say, equation 2. This is equation 3. And then this is equation 4. Okay, so just by substituting the value of your I3 right here, you will now already eliminating one unknowns. okay, or one unknown rather. So in here, you could have I1 plus I2 as your I sub 3 right here. Okay, you can substitute this one right here, and then you can combine the I1 or both I1, and then still two unknowns. Anyway, sobrang hirap ng walang space. Okay, anyway, so here's the values that we have already simplified. So for the loop 1, we have two unknowns, the I1 and then I3. Okay. For the loop 2, we have the I2 and then I sub 3. And then for the third loop, we have I1 and I sub 2. Okay. So from there, you can actually substitute the equation 1 that we have right here. I3 is equal to I sub 1 plus I sub 2 to your equation number 1. Okay. So your equation number 1 is this loop number 1. So sorry for that. We have used two different namings, but in here, the name of your equation 2 is equation number 1. So don't get confused on that one. Anyway, so we have substituted this formula to this I sub 3, forming this newer formula, which is I sub 1 plus I sub 2. Okay, and then simplify it, then you will get this 50 I sub 1 plus 40 I sub 2. Same with equation number 2. Okay, so substitute the value of the I3 to this I sub 1 plus I sub 2, and then you will have this one. All right. And then from there, you have two remaining unknowns, I1 and I2. So you can actually, let's say, solve for the I sub 2 only. Okay. So, paano ko ba ipapaliwanag? Alright. So, let me just copy this one for now. Okay. So, we have this equation which is already substituted by the I1 and I2. Okay. 50 I sub 1 plus 40 I sub 2. From here, you can actually simplify this one into solving one unknown. Like, for example, we have 10. So, ipan ko lang. Sulat ko lang ulit. So, we have 10 is equal to 50 I sub 1 plus 40 I sub 2. Okay? So, this is this one. Okay? Yung pinakauna. So, from here, we could actually form a new formula wherein solving for I sub 1. Okay? Wherein, sige, simplify muna natin. 10 minus, so I'll just transfer this one on the left side. 40 I sub 2 is equal to 50 I sub 1. And then from here, we could transpose this one as your denominator to remain this I sub 1 on the right side. So I sub 1, so lipat ko lang, just flip it. And we have 10 minus 40 I sub 2 divided by 50. Okay. So in here, we now have the formula of I sub 1, wherein you can use this formula to substitute on your equation number 2. Okay. So your equation number 2 is 20 is equal to 40 I sub 1 plus 60 I sub 2. So in here, we can substitute this I sub 1 to this I sub 1 right here to have one unknown only, which is the I sub 2. So 20 is equal to 40 times 10 minus 40 I sub 2 divided by 50. And what's next? 60 plus 60 I sub 2. All right. So were you guys able to follow up to this point?
Yes, sir.
Yes, sir.
Okay, so we are now on this new equation coming from equation number 2. So just distribute this one using FOIL method. So 40 times 10 will give you, so 20 is equal to 400 minus 1,600 I sub 2. Tama ba? 10 minus 40 I sub 2. Yeah. Divided by 50 plus 60 I sub 2. Okay. So from there, we could simplify this one a little bit more. So 400 minus 1,600 I sub 2 plus 50 times 60 is 3,000. Am I correct? 3,000 I sub 2 divided by 50. So from here, we could now combine those two. 1,600 plus 3,000 since they have two the same variable, which is I sub 2. So 20 is equal to 400 minus, not minus, plus 1,400. So am I correct? 3,000 minus 1,600 is equal to 1,400. I sub 2 divided by 50. And then from here, so we can simplify this one a little bit more. 50 times 20 is equal to 1,000. Is equal to 400 plus 1,400 times I sub 2. Then you can transfer this 400 right here. 1,000 minus 400 is equal to 1,400 I sub 2. So we don't have enough space anymore. So magja-jump na lang ako ng solution. So from there, you can actually transpose it as your denominator divided by 1,400. So from there, you can now solve the I sub 2. I sub 2 is equal to 600 divided by 1/4. 600 divided by 1/4. We'll get 0.428. 0.428. Okay, so this is our I sub 2. So let's check whether we get the correct answer. I2 as, yeah, so I sub 2 is equal to 0.429, okay, or 0.428. Actually, the exact answer is 0.4285, wherein if you're going to round it up, it will give you 0.429, okay, which is now this one. So were you guys able to follow on how did we get the I sub 2? From this solution? So that is why, so that is one reason why I would like you guys to do this one on your own paper, okay? That is because, you know, explaining this one without a blackboard is really, really difficult. And at the same time, if you're only trying to solve this one on your mind, it's kinda hard, okay? So yeah, it's possible if you're a genius, but for us normal people, it's super difficult. So, are you guys still analyzing my messy solution?
Okay na, sir.
No. And then from there, since you already have the I sub 2, you can now actually use this one to substitute on your equation number 1, okay, to get the value of your I sub 1. Okay. So we have 10 is equal to 50 I sub 1 plus 40 I sub 2. So palitan natin. Okay, so let me erase this I sub 2 as your 0.428 times 0.428. And then from there, you can now again simplify this one the same with this one. Okay, like what we did. So let me just, can I erase this one now? Is it okay if I will erase this one?
Yes po.
Yes, sir.
Okay, so from here, we can simplify this one as I sub 1 is equal to 10 minus 40 times 0.428 divided by 50. So I didn't show the complete solution anymore, but yeah, here's the simplified version of this one. Okay, so from there, you can now put this one to your calculator, and then you will get, so let me solve this one too. Minus 40 times 10 minus 40 times 0.428 divided by 50. So from here, we will get negative 0.1424. So did you guys get the same answer?
Yes, sir.
Yes, sir.
So let's see, 0.1424. So here it's 0.143 since have used 0.429. So that is why we have a higher decimal number. Anyway, so yeah, we have the same answer. So from here, as you guys can see, we have negative sign, meaning the assumption of the flow of current is actually the opposite way. So I sub 1 is supposedly flowing counterclockwise, okay, not on the conventional way. So it's on the counterclockwise loop or direction, right? So again, if you guys have received a negative sign, just make that one positive. Then you will get a correct answer. Oops. So from here, we can actually already solve the I sub 3 just by putting the values of your I sub 1 and I sub 2 from the first equation that we have a while ago. So I sub 3 is equal to I sub 1 plus I sub 2. So negative 0.143 plus 0.429 is equal to 0.286. Okay, so this is the value of your I sub 3. And then from there, you can now get the value of your R sub 3. Okay, so R is equal to, V is equal to I times R. So 0.286